And here we have a beam, EI. But it's put on elastic foundation. We use a Winker spring. To represent it. Okay? Now we will see for this with different kinds of loading. QX. And what's the diffraction at some point X. So this will be deformed. So we will see the deformation, for different kind of loading, okay? All right? And this is for X, and this is a WX. Okay, and if you take free body diagram for this locating originally here, and it will deform something like this, right? And this is a QX here. And here we have a reaction is equal to K times W at X. The reaction force, right? For example, if this is a cross section at X, and we have a QX. This is a Q. Inside there, we have a uniform loading QX within the X distance. Okay. So it's equivalent to a beam with a Q bar X equal to QX subtract KW. KW, right? And this reaction force is depends on how much diffraction you got. The more W, the more reaction force upward. Okay, so you can see this is kind of a net loading on the beam with a Q bar X and with EI. So the governing equation will be EI W force equal to Q bar equal to Q X minus KW. So this is net, right? And net is from QX and the reaction. So this is the governing equation for a beam with external loading Q bar. But Q bar is similar like a Q with reaction force, Q bar. Okay? So now we come out the governing equation for being on elastic foundation. Okay? So I move this term to there, will be EI. W force derivative plus KW equal to QX. So this is my governing equation for being on elastic foundation with distributing load QX. Understand? So this is another one. You can like, if you previously we don't have this term, so we can integrate both sides, right? We can get a solution of W, but now you have a W term here. You have to solve this fourth order ODE because the W is a single variable function, and this is a non-homogeneous equation. Okay, So for this non-homogeneous equation, you have to solve the homogeneous equation, and you have to solve the particular solution. Okay? Yeah. So this is what we're going to do. Ordinary differential equation. Okay? Did you learn before? No. Ordinary differential equation. Okay, let me show you how to solve it. Okay. So for this fourth order ODE non-homogeneous fourth order non-homogeneous ordinary differential equation. Okay, ordinary differential equation. So the Wx comes times with a homogeneous solution plus particular. So this is what we call the particular solution. So this is a homogeneous solution. Okay. Now let's solve it. Yeah. So the homogeneous equation is EI W fourth derivative plus KW equal to 0. Okay, it's for homogeneous. So how do we solve this equation? First we change this into to this 4 plus K over EI W equal to 0. Okay, we divide EI. And okay, we define this equal to alpha fourth power. That means alpha equal to K over EI, or alpha equal to K over EI 1/4 order. Okay. Then, to solve this, we assume the W, the form of the solution like E exponential lambda x. Okay, lambda x. Then W prime x equal to lambda exponential lambda x. W double prime x equal to lambda square E lambda x. W triple prime x equal to lambda third order exponential lambda x, and W fourth derivative is equal to lambda fourth E lambda x. Because exponential is very good perform for derivative, so that's why we choose this. It's easy. The format will not change, but only with the coefficient from 0 order to the fourth order of the lambda. Okay, so I will get into it so we can get the lambda fourth square exponential lambda x plus alpha fourth exponential lambda x equal to 0, and we can cancel exponential lambda x because it's positive. Okay, and non-zero. Yeah, non-zero. So we have a lambda fourth equal to minus alpha fourth. Okay. Yeah. So lambda squared equal to plus or minus I alpha squared. Right? And I equal to square root of minus 1. It's a virtual number. Okay? And furthermore, this will be lambda will be plus or minus I square root I alpha. Right? Okay. Okay, here, let's see. What's square root of I equal? That'll be I to the half, right? Right? And I also equal to, because we have EI theta is equal to cosine theta plus I sine theta. Do you learn this before? Do you know this before? EI theta is equal to cosine theta plus this, right? So I is equal to, okay, EI half pi equal to what? Equal to cosine half pi plus I sine half pi. All right? EI half pi. Like this. So cosine half pi is 0 plus I, sine is equal to 1. So this equal to I. So I is equal to I half pi. Okay? Right? Yeah. So and EI 2/3 pi equal to cosine and what do we have? Cosine